we are talking rhombi and squares. So a rhombus, which in plural we just found out is not rhombuses, but rhombi. So a rhombus is a parallelogram, so same rules as a parallelogram, opposite sides parallel, opposite angles congruent, all those different things. But the only difference is it has four sides that are congruent. So a rhombus is basically a parallelogram except all four sides are congruent. That's all there is to it. Okay, a couple things about our rhombus. Well, the diagonals, if it's a rhombus, then its diagonals are perpendicular. So that's a new thing. So we already know that they bisect each other because it's a parallelogram. But now if it's a rhombus, we know that the diagonals are perpendicular. They might make a 90-degree angle. So we know their slopes, those diagonal slopes would be opposite reciprocals, right? Because they make a 90-degree angle. Well, next theorem, the parallelogram is a rhombus. So if I have a rhombus again, then each diagonal bisects a pair of opposite angles. So look in here. Each diagonal bisects, that means it cuts it in half. So basically, if I look at this diagonal, I know that measure of angle 3 is equal to, or I'll just do congruence. Let's go angle 3 is congruent to angle 4. I also know that angle 1 is congruent to angle 2. And it just so happens that these are the same as well. So I could say like angle 3 is congruent to angle 1, which means angle 3 is also congruent to angle 2, angle 4 is congruent to angle 2. It bisects. Same thing looking at the other diagonal. If I look at the other diagonal, right, angle 5 is congruent to angle 6, angle 7 is congruent to angle 8. Okay, it all works out that way. So I could also add, angle 5 is congruent to angle 8 as well, and angle 7, all those different ones. So basically, these are all the same, and these are all the same. Okay? They're not all congruent, but by each diagonal, it bisects both sides, the opposite angles. And we're going to end up using that here. So it says the diagonals of a rhombus, WXYZ, intersect at B. Use the given information to find each measure or value. So first things first, I know these are all 90 degrees, don't I? Our last rule, if it's a rhombus, it's all 90. Okay, so keep that in the back of your head. Next thing it says, if WZX is 39.5, so WZX, which is saying this angle, right, because WZX, that's 39.5 degrees. Okay, I want to know what ZYX is. Well, where is ZYX? ZYX. I want to know what this whole angle is. Well, let's break it down. If WZX is 39.5, I know that the diagonal bisects, so I know that this is also 39.5. Okay? Well, let's just deal with this triangle right here for a second. Well, we just talked about that. This is 90 right here, isn't it? This is a 90-degree angle. So far I know that I got 39.5 and 90 degrees. Well, I know that triangles add up to 180. So to find this third piece of that triangle, I just subtract that 90 and 39.5 from 180. So 90 plus 39.5 gives me 129.5. So subtract that from 180. And we get 50.5. 50.5. So I know that this is 50.5 right in here. Well, I want to know what the whole thing is, that ZYX. So basically, two of those 50.5s, right? Because it bisects. So I just double that 50.5. So 50.5 times 2, or 50.5 and another 50.5 for 101 degrees. So I know that ZYX is 101 degrees. ZYX is 101 degrees. So I had to use some of the information. I basically used both theorems I just learned in order to come up with that. Okay, very good. Okay, we got a few more. Well, if I look at this, the diagonals of a parallelogram are perpendicular, then that parallelogram is a rhombus. So this is just kind of the converse of that first theorem. So now I said if I have a parallelogram and I prove that there's a perpendicular in there, then I know that it's a rhombus, right? If I show that the diagonals are perpendicular, I can state that it's a rhombus. Same thing with the bisecting the angles. If I show a pair of opposite angles are bisected by that diagonal, I know it's a rhombus. So right here, if I would prove that 3 is congruent to 4, and I would prove that 1 is congruent to 2, and I knew it was a parallelogram already, I could state that this is a rhombus. Okay, so I can basically use both those theorems, the converse of them, to prove that it's a rhombus. Well, it might be a good idea to give that a shot here in just a sec. But before that, just a few more. If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. And that should make sense because if it's a parallelogram, I know that opposite sides are congruent. So I know that BC is congruent to AD. Well, and I also know that AB is congruent to CD. So if the consecutive sides, like BC and CD, I know that it's a rhombus already, right? Because opposite sides are congruent. That one should make sense. And lastly, if a quadrilateral is both a rectangle and a rhombus, then it is a square. Because if it's a rectangle, that means it's a parallelogram with right angles. If it's a rhombus, it's a parallelogram with congruent sides. And if you think about that, that's what a square is, isn't it? It's a parallelogram with right angles and congruent sides. So if a quadrilateral is a rectangle and a rhombus, then it's a square. So all squares are a rhombus and a rectangle. Every single square is. Okay, well, let's determine whether a parallelogram is a rhombus, a rectangle, or a square, given the following vertices, and let's list all that apply. Okay, so obviously if it's a square, it's also a rhombus and a rectangle. We just talked about that. Let me label my points here. So this guy is B. I don't know why I just put an A. That's B. This guy is A. C is over here, and D is over here. All right, so a couple things. So it's a parallelogram, so I know that opposite sides are congruent. I know opposite angles are congruent. I know that opposite slopes are parallel. All kinds of things. Well, how do I know if it's a rhombus or not? Couple things. I can either show that every single side is congruent, so I could find the distance of AB, find the distance of BC, find the distance of CD, and find the distance of AD, and I can show that they're all equal. That's one way to state a rhombus. This would also help me with the square, wouldn't it? Okay, and then I could show that I have one 90-degree angle, so I could find the slope of AB and find the slope of BC and show that they are opposite reciprocals, because that would mean they're perpendicular. So I could do that, find those slopes, right? Show that they're opposite reciprocals. That seems like a lot of work, doesn't it? I'd have to find 4 distances, and I'd have to find 2 slopes. So let's think about some other rules. What else do we know? Don't we know something about the diagonals here? Let's think about these diagonals. Well, kind of drew that red one in kind of bad. That's all right. Well, what do I know about a rectangle, first of all? Diagonals are congruent. Right? If it's a rectangle, diagonals are congruent. That's one thing I could do. If those two are congruent, I know it's a rectangle. Well, then if it's a rectangle, I know that it would also be a square. So if I show that diagonals are congruent, I already know it's a rectangle for sure, and it might be a square. Well, for a rhombus, what do I know about a rhombus? Doesn't it make a 90-degree angle in here? We just stated that. So I could show that I have a 90-degree angle by my diagonals. For a square, I need both those cases, right? So that's all I need to do. I could just find the distances of the diagonals, and I could find the slopes of the diagonals, and then I'm done. Okay, so really, all I'm going to pay attention to are the diagonals. Not digignals, the diagonals. So I want to find the distance of AC. I want to find the distance of BD. And then I'm going to show that their slopes are opposite reciprocal. So I'm going to find the slope of AC, and I'm going to find the slope of BD and show that they're opposite reciprocals. So first thing, AC, distance formula, take the square root, find the distance between the x's. Well, -2 and 3, they are 5 apart, square it. Find the distance between the y's, -1 and 2 are 3 apart, square it. And then we add those. So we end up with, well, 5 squared is 25, 3 squared is 9, 25 plus 9 is 34. So the square root of 34, and we can leave it just like that. And now we find the distance of BD. Well, distance between my x's, -1 and 2, they're 3 apart. So I have the square root, and we square that. Find the distance between my y's, 3 and -2. Those are 5 apart. So 5, we square that. What do we know? It's got the exact same thing. Square root of 34. So far, I know that this is a rectangle for sure. It might be a square, but I'd have to show that it makes a 90-degree angle. Since the diagonals are congruent, I know it's a rectangle for sure. Well, if these are 90 degrees in the middle, I know it's a rhombus and a square then. So let's check it out. Slope of AC. Let me erase these guys up here. The slope of AC, so subtract my y's on top. 2 minus -1 over, subtract my x's on bottom because y's overrun. 3 minus -2. And we end up with 3 over 5, so 3/5. Then we do the same thing for BD. Check the slope of BD. Subtract my y's on top. -2 minus 3. And 2 minus -1. And we have -5 over 3. So 3/5 and -5/3, those are opposite reciprocals. So I know that it makes a 90-degree angle, which means this guy is also a rhombus. And if a parallelogram is a rhombus and a rectangle, then I also know that it is a square. Now, most of you are going to say, hey, I can tell that just by looking at the picture. Well, I don't really care. Prove it to me. You got to prove it to me with some math. Show me the distance. Show me the slopes. Right? You could have done it some other ways, but this is the shortest route possible dealing with the diagonals. All right, that's everything on rhombi and squares.